Okay, today we're doing a little experiment showing the telegraph devices, and we're going to simulate using these potentiometers here um, long runs of wire and how well they respond by the amount of resistance we add to it. If you look up WD-1A wire, which is what I generally would use, 1 mile of wire would have about 114.7 ohms of resistance. 10 miles would have about 1,147 ohms. And 50 miles of wire would have 5,735 kilo ohms, or ohms. Uh, Luckily, with this just being an on and off pulse of DC, we don't really have to worry about reactance due to capacitance of the wire. Technically, the wire has about 0.16005 picofarad per centimeter of capacitance to it, which over a long run that actually adds up, and if we were talking about field telephones with voices going across it, could become a problem. There's a way to counteract that. You can add in a loading coil, which neutralizes the reactance, but in combination with the capacitance of the wire starts to form of a filter and starts cutting back your frequency maximums. The more coils you have, the more it'll resonate and create a filter effect, and then after a while you basically will start only getting lower frequency tones. Anybody that used to have a 56.6 modem, dial-up modem, and was wondering why they could never get 56.6 speeds, it actually wasn't something the phone company was intentionally using. We had a lot of rumors going around back in the day where they said, oh, the phone company does that intentionally to slow it down. No. A lot of those phone lines have been in there since the 50s and 60s, and they put the coils on there for the same reason, use them on the field telephone to neutralize the reactance of the capacitance caused by the voice signals going across the wires and with the capacitance of the wires. So unfortunately that formed a filter, which while not having that much of an effect on the voice, usually unless it's really long runs with a lot of filters on it. This cat is still in here. Goodbye. The downside is that it cut the higher frequency signals, narrowing the bandwidth, not allowing you to get the full 56 speeds. Most of us couldn't get much better than 38,000 kbps, unless you happen to be on an area that was modern. Now, if you still have a 56.6 modem, if you try it out, if you can find a dial-up BBS and try it out, you'll probably get better results nowadays because a lot of the phone lines have been upgraded. And the filter coils have been replaced with repeaters, basically. Hybrid amplifiers that are bidirectional to amplify the signal, which they actually made for the field telephones back in the day as well. You can get them pretty inexpensively, but they're filled with vacuum tubes and take a 90-something volt by a 98-volt battery and a 3-volt battery to operate them. I might get a hold of one just to see if I can, one, get it running, and two, see if I can come up with a solid state version that would only require like a gel cell battery to operate off 12 volts, good high capacity battery to make it work. But back to the telegraphs here. Currently we're at no added resistance. I've got those dialed all the way down, and of course everything's working just fine. Got all about 2 feet of wire on each side. What we're going to do is I'm going to mount this on a tripod real quick. Okay, so as you see at 0, what we can do is no extra resistance across the coils right here. We're still getting pretty much 0. Everything works fine. But if we add in some resistance, so I can clip into that one. It's a pain to do. Let's just do it from here, right at the junction, like that. And this, let's go ahead and add in 1 mile worth of resistance to it, which would be about 114 ohms. Whoops, that's 300 ohms. Probably a higher precision pot would have been better. There we go. So we got 114 ohms in there. Fix that connection there. So we're getting a good range. Still works good at 1 mile worth of wire. So let's go ahead and turn this up to something closer to 10 miles of wire, which would be 1,147 by the math. So about 1K. There we go. Ooh, almost dead on. So we're at 1,147 or 1.14K ohms. So that would be 10 miles of wire. Probably need to go ahead and adjust this other one as well. Go ahead, I kind of forgot we're going to have to adjust this other one as well to get a good response. So let's tune this one up to the same level, give or take. So it's still working at a 10-mile run. So let's try it up at 50 miles with a wire. Like I said, capacitive reactance isn't going to be a big issue here. And that's just because we're only talking about a pulsating DC. It's not talking about a waveform like a voice. So we're going to turn this up to about 5.7K. 4. It's up to 5K. See, as you get further along, some of these cheaper pot tapers. Well, that's interesting. It's supposed to be a, oh, hang on. That's supposed to be a 10K pot, and I'm only getting 3 out of it. Now, I'm not going to be too amused if that does not work out right. Alright, that's irritating. Let's turn it down. No. Let's check this other one. It's supposed to be a 10K unit, and apparently it's not. I got Fillmore Audio Works, so this is irritating. Okay, this one's closer, but still not enough K. Let's take it up to 5.7 right there. Okay, let's try the other one again. See what I can do. Okay, this one's now reading more like what it's supposed to. Okay. So those are both set to 5.7K, which is equivalent to 50 miles of wire. Now we've lost signal. So what we can try doing is reducing spring. There we go. Cut the spring was too strong. So let's adjust the spring up, down, let's set the gap down. Okay, cut the spring back some. Had to set the spring down to about 0, the gap up to about 4. This one won't respond, so let's trim it down a lot. Let's bring it up to about 4. See, so at 50 miles with just 9-volt batteries running about anywhere from 27 to 28 volts, depending on how much life is left in them from all this use. You can see on a simulated 50-mile run of wire, if you just adjust your relay mechanically, you're controlling the tension on the spring and the gap on this one. And on this one, I think it just adjusts the spring only. That's it. Let's try something here. Have a good clean signal. Getting SOS pretty cleanly. So as you can see, we get a pretty good run out of it. Pretty much I doubt it could go much higher on the resistance and still get a good read. But 50 miles, I mean, for a couple of units running on 3 9-volt batteries apiece, that's a lot. That's a lot of run, you know. But anyway, they said you can see some improved performance by putting a loading coil in on each side on long runs. It actually, capacitive reactance, according to the manual on these, can play some part in it, just not as much as it does on telephone circuits, so I have to speak over. Other than that, you know, these are impressive little devices. They're built in the 40s. According to the serial numbers on them, they're both built in the early to mid 40s. And, you know, they're pretty well taken care of. Blew some dust out of them, cleaned the contacts. And that's really all I did, except rig up a battery pack for them, and they work fine. This goes to show you that military used to build quality equipment, or have quality equipment built for itself. Just nowadays, I just don't see that happening. Everything's made out of plastic, and it breaks all the time. Alright, well, anyone got any questions, I'll try to answer them as best as possible. Have a good day.